Chemical kinetics assignment 2. This is your Lakshma Reddy sir, the question number 11. The relation between the rate of a simple reaction and the concentration C of the reacting species is given as rate is proportional to C to the power n, where n is order of the reaction. Order may be positive, negative, zero, or fractions. Which of the following about the rate constant K of a reaction wrong? See here, it should be wrong. It remains unchanged throughout the course of reaction, right? It provides convenient measure of reaction rate, right? It is expressed in the same units for all reactions, no. Only for zero order reactions, rate units and K units are same. For remaining all, it is not same. So this is a wrong statement. The more rapid the reaction, the larger is the value of K. The slower is the reaction, the smaller its value is 100% right. So option 3. The value of the rate constant of a reaction depends only on temperature. When you are increasing the temperature, rate constant value also increases. It depends only on temperature. For a reversible chemical reaction, the concentration of the product with time, product concentration generally increases. Irreversibly mentioned, so unidirectional reaction, so product concentration with time will be continuously increasing. For the reaction of 2NO2 gives rise to 2NO plus O2, which of the following is false? False. The decrease in NO2 and the increase in NO proceed with the same rate. How do you write this expression? See, minus 1 by 2 dNO2 by dt, right, is equals to 1 by 2 dNO by dt is equals to dO2 by dt. So both are same, na? Correct. So this statement is right. The rate of formation of NO is twice the rate of formation of O2. You see, if you want to bring this 2 here, it will go up, and that is only mentioned here. So this is right. It is also right. The average rates of increase in the concentration of NO and O2 are expressed as, for NO it is not right, it must be 1 by 2. So this statement is a wrong statement, false statement, so this is your answer. The rate of gaseous reaction is given by KAB. If the volume of the reaction vessel is reduced to 1/4 of initial volume, the reaction rate relative to the original rate is very simple. When you are decreasing the volume by 4 times, concentration increases by 4 times. For A increase 4 times, for B increase 4 times. So 4 into 4, that is going to be 16 times. 4 into 4, 16 times, because when you are decreasing the volume, concentration increases by 4 times. Decreasing the volume by 1 by, decreasing the volume to 1/4 means increasing the concentration by 4 times. 17th one, the rate of a reaction A gives rise to product, say 10 moles per minute when T is 2 minutes. Okay, now, so initial time you can say. The rate of reaction at 12 minutes. Very simple logic. As the time passes, rate of reaction decreases. As the time passes, rate of reaction decreases. Decreases. A chemical reaction was carried out at 300 Kelvin and 280 Kelvin. The rate constants were found to be K1 and K2. 280 Kelvin, if it is K2, 290 Kelvin, it will be 2K2. Why? Temperature coefficient generally 2, if not mentioned, you take 2. 300 Kelvin, again double, 4K2. So K1 is equals to 4K2. K1 is equals to 4K2, or K2 is equal to 1 by 4 K1, or 0.25 K1. The differential rate law for the reaction H2 plus IT gives us to 2HA. Very simple. Minus dH2 by dt is equals to minus di2 by dt is equals to 1 by 2 dhi by dt, right? So this 2, if you want to remove from here, 2 will come here, 2 will come here, and 2 will go. So this is the expression. Exactly right. Observe the following reaction. A plus 3b gives rise to 2c. The rate of the reaction minus dA by dt is 3. So how you write? Minus dA by dt is equals to minus 1 by 3 dB by dt. And what is asking? Only minus dB by dt. Means this 3 should come here. When 3 is coming here, already 3 into 10 to the power of 3 into 3. So that will become 9 into 10 to the power of minus 3. Right?